Hey everyone, welcome to my channel. In this video, we are going to learn the latest face and eye detection method that runs at an amazing 60 frames per second, and all of this on an HD resolution. This is a lightweight model provided by Google, so it runs on CPU and mobile devices as well. If you'd like to create real-world computer vision apps, do check out my premium course in which we learn how to create apps such as object detection, augmented reality, document scanner, and a lot more. The link is in the description below. So without further ado, let's get started. So here we are in our PyCharm project, and the first thing we will do, we'll go to File, Settings, and we will go to our project and the interpreter, and we will add. So here we are going to add OpenCV-Python, and we will also install MediaPipe, which is the library that will help us detect the faces. Okay, so now both of them are installed, and here on the side you can see that our project is called Face Detection Project, and then we have a folder called Videos. So let's open that up and see what it contains. So here is the folder, and we have a total of 6 videos that we are going to test on. Now you could do it on a webcam as well, but I'm going to do it on a video because one, it will be more clear, and second, with the webcam you will have a limit of the frame rate, so with the videos you will have faster frame rates. Okay, so we are going to right click and we will go to Python file, and here we are going to create our project. So we will call this Face Detection Basics. So the idea is that we are going to look at the very basics, the bare minimum code that is required to run it, and once we understand that, we are going to go ahead and create a module out of this so that we do not have to write it again and again for different projects. So the first thing we will do is to import CV2 and then import MediaPipe as MP. This is so that we don't have to write MediaPipe again and again. We can just write MP, and then we will import time. This will be to display the frame rate. So first of all, we are going to run our video. So we will write here cap is equals to cv2.video capture, and we are going to capture from within our video folder. So we will write here video slash 1.mp4. So this is the video that we will be using, and then we will write here while true. We are going to write success and image is equals to cap.read. So that will give us our frame, and then we are going to write cv2.wait key as 1, and we will also write cv2.imshow. We will write image and then image. So this is pretty much, you can say, the boilerplate of our projects that we have been doing. So we can simply right click and run this, and we have an issue cv2 dot it's called videos, it's not video. Okay, so there you go. So this is the video that we will be using, and as you can see, it is going pretty fast because it is running at a higher frame rate. So you could reduce the frame rate from here. For example, if I put 10, you will see that the frame rate is it's much closer to real time. But we are not going to do that. Instead, we are going to display the actual value. So to do that, we will simply write here ctime is equals to time.time, and then we will write fps is equals to 1 divided by our current time minus the previous time, and then we are going to write that our previous time is equals to the current time, and then we can display it. So we will write cv2.putText, We'll put it on our image. We are going to write FPS. Oh, I wrote it wrong. F and then FPS, and then we will write curly brackets, and inside that we are going to write integer and then FPS. And what else? Then we need to define the position. So let's say 20 and 70. And then we are going to write down the font. So cv2.font, let's take the plain one. Then we have the scale, let's put it as 3. Color, let's put it as blue or green. Let's put it as blue. 255 0 and 0. Okay, then we will write, let's say, the thickness, and yeah, that's pretty much it. One more thing we have to do, we have to declare the p time for the initial frame because it is not defined before and we are using it here. So we need to define before that, and all of this needs to be before the image show. So we are going to put it down here, and we can simply run this and see what happens. There you go. So you can see the frame rate is extremely high, 140s, 160s, something like that. Blue might not be the best color, so let's put it as green. Let's try that. Yep, that's much better. Okay, so now that we have our frame rate, by the way, as I was mentioning before, you can reduce the frame rate from here. Let's say I put 20. So now you will see that, yeah, it's much closer to real time. It's around 30 something, 40. By the way, this video is a slow-mo. So that's why it looks a little bit slower, because the video itself is a slow motion video. So if I open it up and I play this, you can see this is actually a slow motion video. Okay, we could use the second one as well. Yeah, this one looks real time, or it's hard to tell. Okay, we could try it with the second one here. Let's see how that works out. Yeah, it's not real time either. Okay, so anyways, so that's the idea. So we will keep it as 1 because we are going to process it, and hopefully we are going to get a good frame rate. So you can see it's quite fast. So what is the next step? The next step is to import our media pipe functions or classes so that we can use them. So here what we will do is we will use the face detection module. So we will write here MP face detection is equals to MP dot solutions dot face detection. Yeah, okay. So then we need something to draw. Now we can draw ourselves as well, but we can import the drawing part here as well. Let's say MP draw is equals to MP dot solutions, and then drawing utilities. Okay, so basically this will allow us to draw without going into the details, but if we want to draw ourselves, we can do that too, because drawing a rectangle should not be that hard. But we are getting a few points as well. We will be getting 6 points, so for the eyes and the nose and the ears. So we could simply draw them by using this. Okay, then we are going to write face detection is equals to MP face detection dot face detection. So this basically initializes that we are going to use a face detection. Again, my spellings are wrong, to fix that. Okay, so then we can simply go, and this is an BGR image, so we need to convert it into RGB before we do that, before we send it to the media pipe library. So we will write here image RGB is equals to cv2.cvt color, and we will give in our image, and then we will write cv2.color underscore bgr to RGB to RGB. Okay, so then we will write here that our results is equals to face detection dot process, and we want to process our RGB image. So this is the idea. Whatever the output is, it will be stored in the results, and then we can process these results. So we can print this out. We can write here results, and let's try it and see what happens. There you go. So now all of a sudden you have seen that the frame rate has decreased. So if I don't run this and I don't print this, you will see that the frame rate is very high. But as soon as I run it, the frame rate reduces to around 60, 70, I can even see 90s. So yeah, so it means it's working at the backend, and it is giving us a class. So they have their own class by MediaPipe Python solutions. So what we need to do is we need to know how to extract the information out of this. So we are going to do that next. So here we are going to write, so it can be multiple faces. Actually, let's go to a video. Let's go to the first video again, because it has multiple faces. So we will check if the results dot detections is available. Then we are going to write for ID and then detection in results dot detections. Okay, so we are going to find in that, but it should be enumerate because we want the ID number as well. So we will write this, and then we can loop through each one of the results and we can display them. So we can write here print detection. So whatever we have, it is being processed here, and what we can do is we can display it with the ID. So we can write ID and then it will show us the detection. So let's run that. Okay, there is some issue here. Where is it? Results dot, again the spellings, detections. Okay, so if I close this and if I go up here, you can see these are the key points. So here it is saying that this is detection number 1, this is ID number 1, and they have given it a label of 0. This is the score. This is 91% sure that it is a face. Then there's location data within it, which means the bounding box. And then there are key points. So 1, 2, 3, 4, 5, and 6 key points. So you can use these key points as well, but we are more interested in the face itself. So here you can see this is 0, this is face number 0, and this is face number 1. So the label ID is same because both of them are faces. And here we have face number 1, and here we have face number 0. So now we need to know how to extract this information. So we already know that this is a class. So what we can do is we can, for example, if we wanted the score, we will write detection.score. So if I write here detection.score, that will give me the value of the score. So I can print that out. What happened there? So if I print that out, you will see I'm getting the detection by itself. So separately, I'm getting the value. So I can get that. Then how can I get the, for example, the X minimum? So this is the XY position that we want. So to do that, you can see that we have, first of all, location data. Inside location data, we have relative bounding box. So we need to write that. So we will write here print. We will say location data. First of all, detection dot location data, and then we will write dot relative bounding box. So that should give us the values. So let's comment these and let's run this. And there you go. So now we simply have the information of our bounding box. Okay, so that is good. Now, what else can we do? Now, the thing is that these are, you can say, normalized values. So they are normalized between 0 and 1. So what we need to do is we need to multiply them with the width and the height to get the pixel values so we can draw. But before we actually go into the drawing, we can also draw by the function that they have provided. So that function is mpdraw dot draw landmarks or draw detection, and then we have image, and then we have the detection. So yeah, that should draw the faces for us. There you go. So now you can see we are getting the points and we are getting the faces, the bounding box around the faces. Now the thing is, for me, the points are not very accurate. I don't see them being useful. You can see sometimes maybe you will get a better result. Maybe, let's say video number 2. Let's try that. Yeah, here it's a little bit better. You can see the eyes and the nose. And let's try number 3. Yeah, here for the baby, you can see it's quite good. So again, if you want to use the points, then you should make sure that the video is quite zoomed in. The focus is on the face. So if you want that, you can use the points for the eyes and for the nose and for the ears. So the same way we got the information of the X and Y and the score, the same way you would get the information of the landmarks. But I'm not going to go into the landmarks. I will just keep on the bounding box. We will focus on the bounding box, and we will also focus on the score. So these 3 things are what we are interested in. If you want more, you can add on to it. So now that we know how to draw this, what we need is we need to draw ourselves. We need to get the bounding box information so that if we want to use it, just the numerical values, we should have access to those. So what we will do is, instead of using all of this, so if I wanted the value of X minimum, I would have to go inside this as well, and I will write X minimum here. Now that is a very long call for just one value. So we need to shorten it so that it is easier to work with. So what we are going to do is we are going to store all this information in a bounding box. And from that, we are going to extract these information. We are going to multiply. So what do I mean by that? Let's have a look. So we will say that our bounding box coming from the class is equals to detection, all of this, detection dot location data relative bounding box, all of that. So that is the bounding box coming from the class. That's why we wrote C in front of it. But then we are going to convert it in our own language so that we can work with pixel values rather than just the normalized values. So we will call that the simple bounding box without the C. And what we need to do is we need to write here that our bounding box C dot X minimum multiplied by our width. Now, but we don't have the width. So what we will do is we will write up here that our image height, then our image width, and our image channels is equals to image dot shape. And then I can use here I width, image width. By the way, this I here is not a big deal because defining variables is about scope. Where is it being used? If it is being used in a lot of different places, it has a very wide scope. Maybe it's being used out of the function, out of the loop. Then yes, then you need to define long names that are clear, like here, location, data, relative, bounding box, and whatnot. But if you are using it in a small scope, for example, when you use for loops, you write for I in range, right? So why did you write I? You wrote I because you are not going to use that I outside this for loop. The scope is very limited. So if you're writing IW, IH, or even WH, it's not a big deal. So then we are going to convert this into integer, and then we are going to copy this, and here we are going to write that we need the y minimum, and we are going to multiply this with the height. So that's the idea. And then let's go to the next line. So we'll put a backslash, and then we will copy this, and here we are going to write width, and we will keep it IW, and here we will write height. So now our bounding box will have X, Y, and width and height. So we can simply use to draw this using a rectangle function, or we can use these values outside in our project. So that should be good. So what we can do is we can write here cv2.rectangle, and we will put the image, and we will say the bounding box. We can simply feed in the value because it contains all the 4 values. It will understand. And then we will, let's make it purple, 0.255, and let's make the thickness of 2. So that should be enough. Let's remove this. So note that we are not drawing by default. So we are not using the default function to draw. We are drawing by ourselves. So let's run that. And there you go. So now we are getting a clean box, a bounding box that is quite nice. There you go. You saw here, yeah, you can see here we are getting some false detections as well. So what you can do is you can change the what do you call, there is a parameter here, minimum detection confidence. So you can change this. So you can write here, it's by default it's 0.5. You can write, let's say 0.75. Hopefully that will remove that. There you go. So now you don't see the false positives. Okay, so that is good. Now what else can we do? So this is quite good, and the only thing we might want to see is the confidence value. So the confidence value, or the score, as I mentioned, you can get by detection.score, and we can put it, let's copy this, we can put it on the bounding box, and here we can write, for example, that we have, let's keep it integer, we have detection.score, and we are going to get the first element of it. If you don't get the first element, it will just put a bracket around it. So it has only one value, but it will put a bracket around it. So we are just removing that bracket, and we can multiply it by 100 so that it is a percentage. And we can write outside that this is a percentage, and we don't need to write anything at the beginning. And the location should be bounding box at 0, BBOX at 0, and then bounding box, I think that is way too much. Okay, let's bring that down too. So bounding box at 1, but we are going to subtract -20 from it so that it is easier to see, it is not overlapping with the box. Okay, so let's run that and see if it works. There you go. So we are getting 90 something % of score, the confidence level. So I think it should be the same color, so it looks blended in. So we will put it here, 255. What else? I think the size was big too, so we can change it to 2. Yeah, that looks much better. So let's try out the first video. There you go. So that's pretty good. We are able to detect with the score and with the bounding box value. So now this is good, but the problem is that you can see that there's quite a bit of code that you have to write to find the face and to get the values that you can use. So what we can do is, instead of initializing and writing all of this code again and again for different projects, what we will do is we will create a module out of this. so that we just import that module and use it whenever we want. Okay, so how can we do that? So we are going to go to Python file and we will call this face detection module. And here we are going to copy all of our basic code. Now the first thing for the module we need is our if statement. So if we have the name underscore name is equals to main. So this means that if we are running this file, then we need to run main. So whatever is in main is like the dummy code. It is kind of a hint that this is how you can use this module. So we are going to declare here that this is main, and inside main we are going to write our while statements. So yeah, let's copy this part. We will paste it in the main. Then we have the while. So we will just read the frame. And then we have the ending part. We will put the frame rate as well over here. So yeah, that should work fine. Then we are going to, okay, so then we are going to create our class. So we are going to call this face detector. And we are going to define our initial function, initial method init. And then inside that we are going to write, okay, let's leave it for now, or let's write it. Minimum detection confidence. Detection confidence. Okay, that should be fine, and we will give it a default value of 0.5. Now the thing is that we need to put everything which is related to initializations over here inside. So we will take this and we will put this in, and we will remove some spaces. First of all, we need to write here self dot minimum detection confidence is equals to minimum detection confidence. So in objects or in the classes, all we need to do is we need to write here self dot, and here we will write self dot, and self dot. So it is not a generic variable or a global variable. It is now an instant variable. So whatever we are defining is for this class or for this object. So that's why we are writing self. Okay, so that is good. Now we need to define another function or a method called find faces. And we need an image. Do we need anything else? We can put a flag of draw. So draw is equals to true by default. So we are going to put all of this in, and let's see what do we need to change. First of all, we need to write the self dot. So here we will write self dot face detection, and then we will also write self dot results. Self dot results in case we want to use it later. It's not really required at this point, but anyways, so we will comment this. We can remove all of this. And what else? Okay, so now we need to return something. So we are finding the faces, that is all good, but we need to return all these faces. So what we will do is we will return the bounding box information, the ID number, and also the score. If you want to return the landmarks, you can return that too here. So what we will do is we will create a new variable, a new list, and we will call it bounding boxes, plural. So we will make it empty, and all of this is being done for one face. So it is showing and it is processing face by face. So what we need to do is whenever it processes, we need to put that in our bounding boxes. So here, when we have our bounding box value, then we can send in whatever we want. So in this case, we are going to send bounding boxes dot append, and we are going to append first of all the bounding box, and then we are going to append the detection dot score. So if you want, you can append the ID as well, but normally it is the same. What do you call? It will have the same list number, the index of the list. So it is a bit redundant, but anyways, if you want, you can add this too. So this is the idea. Then we simply return these bounding boxes. So we return bounding boxes, and we also return the image that has all these detections on it. So that is the idea. So by now we should have it running. Let's try it out. So we are going to create an object from our class. We will call it detector, and we are going to write that our face detector, and we are not going to give in any value. So by default it's 0.5. We will keep it 0.5. So once we get the frame, we are going to write here image is equals to detector dot find faces, and we will give in our image, and we will keep it the draw as default. So that is good. Now if we run this, it should pretty much run the same way as it did before, and there's an error. So inside of main, okay, so here we are facing an issue with the bracket probably. What is it? Image, this is fine. I think it seems fine to me. Let's go here and copy this. Yeah, it's exactly the same. So it should work. The error is not here. It's probably because it's not finding the image. Okay. Let's remove this part and try it. Yeah, it is about the image. It's not able to get the video. Why are you not able to get the video? Are you not able to get videos 1.mp4? Okay, let's remove this as well. Ah, okay, I get it. My bad. There are two parameters that needs to be returned, so we need to write here bounding boxes. Yeah, that was the issue. So let's run this. And there you go. No, this is the module. Yes, this is the module running. Okay, so that is good. Now it is running. And okay, it's not detecting properly. Why? Did we change the... We can change the value here. So maybe let's say 0.4, but it was working before. Yeah, here it's 0.75. That's the issue. So we need to put this here. Minimum detection, self dot minimum detection. Okay, so that is good. Now we do not need to do 0.4 here. By default it's 0.5, so it should work fine. There you go. So now it is detecting properly. Okay, so that is good. Now it is working as a module, and we can get the information. By the way, you can just print here, print the bounding boxes, and let's see, what do we get? There you go. So now you're getting the information. So this is face number 0, this is the bounding box, this is the confidence, this is face number 1, bounding box, and the confidence. So you can extract this information and use it very easily. So by now we are pretty much done, but I want to do something else. Now this is, you can say, kind of a fancy thing. If you want to do this, you can add it, but it is of course not necessary. So what I want to do is, we are always showing these bounding boxes the same way. We are just drawing a rectangle and it's very plain. It doesn't look good. This is a new method, so I want to show it in a new way. So what can we do? So what I was thinking is that we can put some corner, lines a little bit thicker. So that will give it an image of like a target. So whenever you have a target, you have these edges that are thicker, and then you have the bounding box in between, something like that. So let's try to add that here. So what I will do is, I will create a new method here, and I will call that, let's say, fancy draw. Instead of regular draw, we are going to do fancy draw. So we are going to write here that we need our image and we need the bounding box. So we will do one at a time. So just send us one bounding box and we will put the bounding box around it, then send the next one, and then so on. It will not take an array. Okay, so then first of all, we are going to open it up. We are going to extract the information from it. So we are going to write here x, y, width and height is equals to the bounding box. And then we also need the x1 and the y1, which is basically equals to the diagonal point. So x and y is the first point, or you can say the origin point, and then x1 and y1 is the bottom right point, so the corner points at the diagonal position. So rather than calculating it again, we can just define it right now. So we can write it as x plus width and y plus height. So now we have all the information we need. Now we can start drawing the lines. So here we will write cv2.line, and inside the line we need to send in our image, and then we need the starting point. So I will say the starting point is x and y. Then we have the x plus a certain value. So this is the length of that line. So let's write here length is equals to, let's say, 30. We will write here length, and then we are going to give in the value of y. So y will stay the same. So then we will give it a color. The color will be the same as the rectangle. So we will write here 255, 0, 255. And here we have to write the thickness. So let's write here that this is the thickness is equals to, let's say, 10. So I will write here, T. So it might be a little bit confusing at this point, but let me show you how it works. So let's remove this rectangle from here, and I will put this here, rectangle, and then I will write here fancy self.fancy draw, and I will give in the image and the bounding box. So that's the idea, and it will return the image. So we can write here return image. Okay, so let's run this and see what happens. So there you go. So now you see there's a thick line on the corner. Now we need to draw the line at the bottom. So let's draw that. So we will copy this and we will paste it here. Now this time around, the x will be without any extra value, no length for the x. We will add the length to the y. So if we run it again, now you see we have a corner point. So we have a corner, we have two lines at the corner. So what we need to do now is we need to replicate this on the others. I think the thickness for this should be 1. We can give it, let's say rectangle thickness is equals to 1, and we can put here RT. Let's run that. Yeah, this looks much better. Okay, so, and even the thickness for this is too much. Let's put it as 7, let's say. Yeah, it's getting better, maybe 5. Yeah, that looks good. So next, what we can do is we can write here that this is for the top left, which is basically for X and Y. Okay, this is the point X and Y. Then we will copy this and we will paste it here. And we are going to say that this is for the top right. And now our position will be X1 and Y. So we will just change this to X1 and that should work fine. X1 and Y, yeah. So one more thing is that if I run this now, you will see the issue. It is going outwards. We need to bring it inwards. So how do you bring it inwards? You simply subtract the length instead of adding in the X direction. So there you go. So now it's inwards and it's done. So we need to do the same for the next two. So we will copy this and we will paste here. So for the bottom left, and then we have the bottom rights. So for the bottom left, we will have X and Y1. So we will just replace this with Y1 everywhere. And then this will remain positive, but this will be negative. Again, you can play with these and you can see if it gives you a problem, then you can replace it if you don't understand it directly. So this is the third one. And then for the fourth one, it will be X1 and Y1. So we will write here X1 and Y1, and the values will be both minus. So both of them will be inwards. There you go. So now it looks much better than just a rectangle drawn around it. So, and yeah, one more thing I forgot to add is the condition for drawing. So if we want to draw or not. So here I can write if draw, then we do this. Otherwise, no need. So if I run this, it will draw. If I go back here, and where is it? Here. And if I put this as false, it will give us the values, but it is not going to draw. Oh, what is that? We didn't put that in the draw. Yeah, this needs to be in the draw. There you go. There you go. So now it's not drawing anything at all. And if we go down and we write here nothing, then it will run because by default it's true. So as you can see, now we have our face detection, which is running almost at 60 plus frame rate, which is pretty amazing given that we are only using a CPU. And this is an HD video, so it is 1280 by 720. If we are running even lower than this, for example 640 by 480, the frame rate will be crazy high. So you can keep that in mind. Let's try this one. It's pretty good. Let's try, how many do we have? We have 6 videos. Let's try all of them. This is number 4. It's pretty good. And you can see here, see, that's the thing with hard cascades, that it does not detect on the sides. So if you rotate your face, it will not detect at all. But this one does. So that is pretty cool. There you go. Oh, this kid is really enthusiastic. Then number 6. There you go. So even on the side, but if it's gone too far, maybe it will not detect. But here you can see it's blurry and it's on the side, and even then it is detecting quite a bit that there is a person there. So that is pretty amazing. So this is how you can detect your faces using this media pipe library. And you can see that we are getting a 60 plus frame rate, which is amazing for an HD video, and we are only using CPU. So this is pretty good. And this is pretty much it for today. I hope you have learned something new. If you like the video, give it a thumbs up and don't forget to subscribe and do share it with your friends if you like the video. And I will see you in the next one.